All right, agenda. Who is this for? Developers, engineering managers, PMs, execs. There's a little bit of everything in this presentation for that group. This presentation provides some insights from a UEFI supply chain partner as they set out to maximize their security posture. So who am I? I haven't met many of you. I haven't been in the UEFI space for too long. I've been with AMI for 2.5 years. I was brought in to stand up this SSDLC organization, as we call it. I have over 20 years of experience in firmware development, so I've been grinding out code for most of my career. Done some pretty exciting things, at least I thought they were exciting. Before I came to AMI, I led a project for Comcast, a Wi-Fi access point and cable modem. We fielded this guy nationally. You may, if you drive around, you can see those things hanging from the telephone wire still. So, all right, before we get this kicked off, let's do a little SSDLC primer, and you may have seen some of this from previous presentations, but I'll gloss over it briefly. I mentioned SSDLC. So what is So what is SSDLC org? It's the organization that I lead. It's a decentralized product security team with a mandate to implement SP 800-218 across the engineering organization. We heard about this already. I'll cover it. I'll touch on it in a second. What does decentralized mean, though? Security orgs can be modeled as a decentralized org, as a hybrid org, or a centralized org. When you say decentralized, envision an organization crafting processes for all the engineering product lines and kind of distributing those processes down to the teams and having them implement the processes. So they really don't get into their day-to-day operations. Hybrid is a little bit of both. So if we were a hybrid organization, we would create the processes, but we would also know some specifics about the day-to-day activities of the engineering teams, about their tools, about their processes, and we would account for those. Centralized, where actually your security audit is actually embedded within the engineering teams, even to the extent of maybe even creating the remediations themselves. So when we first set up this organization, we wanted to do it just because of resources available to us in a decentralized model. But as you'll see, it kind of evolved into more of a hybrid model, especially on the Reactive side. So what is Special Publication 800-218 about? And there's a sequence, there's an order here. So I'm looking at this from an organization that wants to improve their security posture. So where we are in the supply chain is an IFE. If we were just starting from scratch, which we are, this would be my recommendation where you'd want to start. A lot of people don't have the resources to tackle all of these at once. It's a big spec. So I recommend starting off with protecting your software. That's implementing systems to provide for a secure release to your customers. Implementing systems to provide for secure development environments. You want to ensure that only authorized people are able to develop that code. And if you're dealing with binaries, code signing as well. Second, you're going to want to mature the part of your organization that handles vulnerabilities. You don't want to be caught flat-footed when the supply chain is reporting vulnerabilities to you, you want to be able to respond efficiently and effectively. So you want to organize that PSERT. So we talked about a PSERT, right? So make sure you set something up. I mean, some people start with spreadsheets, emails and spreadsheets. That's kind of an entry-level PSERT. Thirdly, you can move into preparing the organization. So this is getting into a little bit of governance, processes, roles. I can speak a little bit about governance from my perspective. We have a dual reporting structure. So I report to the Chief of Engineering as well as the CISO. There's benefits to this. In our organization, the CISO has a direct reporting line to the Board of Directors. He assesses risk for the whole organization, which is enterprise security and product security. It allows me to operate with a sense of independence from the engineering org, which prevents subversion. So if I have visibility into problems in the engineering org, it's less likely that those would be concealed or not reported to the Board of Directors. But there's benefits also to being part of the engineering org, and that I can actually work closely with the engineering teams and get my processes implemented into them, get them prioritized. And then finally, produced well-secured software. So this is proactive security. Your reactive security is going to give you insights into what you can do for proactive security. Reactive security is addressing the issues after a release. Proactive security, so this is think of number of vulnerabilities detected in your release code. Proactive security is reducing that number, so catching the vulnerabilities before they get into your release code. Okay, we're going to focus on, I originally crafted this presentation to talk about proactive and reactive security, but due to time constraints, we're going to focus on the reactive side. There's been a couple presentations that have shown this type of visual, so I think we've convinced you why we need security. Different visualization, I looked at high-profile UEFI vulnerabilities over the past several years and charted them out, and just to see what the trend is here. Looks like there's been an uptick in the last several years. So I zoom in on 2021 to 2023 and tap into our vulnerability database specifically, and this is what AMI is seeing as reported to us from various sources, researchers, CV scan tools, etc. So you can see that there's been a significant uptick in the last couple of years. So I don't think we have to argue the point that security is needed. Why invest in a secure software development lifecycle? First of all, you want to reduce risk to the supply chain. You want to react better or faster when vulnerabilities are identified. We've talked about these government mandates that are looming, including the executive order and related, this special publication. Brand reputation. This is a big one. So this is where I get my interaction with the board. If there's anything from product security that affects the board or affects the brand, the board usually gets involved with that very quickly, and they want to know what's going on there. So brand reputation is important. And operating costs. If your issues get into a release, PSERT is expensive. It's very expensive. So you want to catch these things early in the development cycle. So you want to shift all of these things left, if possible, into the proactive security side. So how do you implement SSDLC or mature your security posture? You got to get out of the cycle of reacting. You got to move out of your P-cert. You got to get ahead of things. And to do that, your organization has to invest. So yeah, that'll get you into, that'll shift you left into the proactive security side. So how do you break this cycle? Properly staff the team, and here's what I'm doing within my organization. I've got 75% of my team are software developers. 25% are security engineers. So they handle compliance, auditing, process, training, things of that nature. 75% of the team is cranking out tools and systems to automate and modernize product security. Okay, 1 second. So reactive security. Reactive security is implemented with a P-cert. For my organization, the P-cert is responsible for creating the processes, P-cert processes for the team, creating security remediation processes for the engineering teams, creating tools and systems for vulnerability management for P-cert and product engineering, as well as the customer engineering teams. We do risk assessments, as Dick was talking about with CVE creation and risk assessment, where we handle those duties. And we publish advisories, so we keep all the downstream supply chain partners informed on the vulnerability remediation status. And we work with the product office of marketing and security blogs and things of that nature. And again, we started out thinking we could do this decentralized, but we moved into a hybrid structure, and I appreciate executive management for giving me the resources that enabled me to do this. So in order to handle scale within your organization, and you've seen what the vulnerability counts have suggested lately and the attention that we're getting, you're going to have to handle scale, plus your organization is going to add more products in the future, and you're going to want to do a lot of other things. You're going to, if you have a vulnerability detected in one product, you're going to want to be able to track it across all the products in your organization, track the life cycles on all of those. So you're going to have to modernize. You're going to have a modern vulnerability management system. I looked at off-the-shelf systems, and I worked under the assumption that it was going to be just as much work configuring those tools as it would be for me to create the system from the ground up. So creating an architecture, and this represents our vulnerability management system that we're using. So at the bottom layer of the stack, you have a database which maintains all of the vulnerability information. We have a services layer on top of that we can do lots of things with, including a web interface that other internal teams can interact with to get vulnerability status. If there's customer inquiries that come in, they don't have to take up my team's time. They can look up the data in the database themselves. We can implement a bunch of cool scanning tools and facilitate automation on top of the services layer, which we do. So these scan tools, we integrated into the engineering's SDLC. So they run it on their code. It can detect new vulnerabilities in their code and have it automatically fed into the VMS system, which kicks off a vulnerability lifecycle automatically. So that's cool. basically shows you all of the vulnerability sources that you have to deal with. CVs, we cross-reference the open source. We know that exists in our products with NVD, so we're always, if a new CV is drafted against some open source that we use, our scanners pick that up immediately from NVD. Tianocore, of course, generates sightings. Silicon vendors, our BMC product uses Debian. We get emails, we have a website, people email us vulnerabilities. And then our issue tracking system, customers get approached by researchers and they pass the sightings on to us through our bug tracking system. So we have to scrape all of the new vulnerabilities out of these systems and get them ingested into our vulnerability management system and begin P-certs on all of them. So I mentioned a vulnerability scanner. My team has implemented a vulnerability scanner for all the products in the company. So the tool can look at the code and it's cognizant of what it's scanning. It knows if it's a UEFI product, it knows if it's a BMC product, etc. It knows what chipset it is. So it can do special things based on that. It's kind of an abstraction. So depending on the project that it's scanning, it may use an underlying different scanner. It may use Black Duck. It may use something custom. For UEFI, we found that off-the-shelf vulnerability scanners didn't work as well as we wanted them to. So we created a custom implementation. And just the nature of the supply chain, there's snippets of open source sprinkled everywhere in the supply chain, and it's not, we don't have good SBOMs yet. We don't communicate what open source we're getting from upstream providers. So I worked with the engineering team here to create an open source audit of all of our products. And we create and manage a database of all the open source in our UEFI products, which is also used for SBOM. So you'll get this information in SBOM as well. So when the scanner looks at UEFI code, it knows what project it's seeing. It cross-references with the database to get the open source that's known to be in that project. And then it looks it up on NVD to see what new CVs are known against it. If there are any new sightings, it feeds it into the vulnerability management system, which begins the P-cert process. So I've talked about life cycle, vulnerability life cycle. What is that? So it begins with a sighting. When somebody finds a sighting or reports a sighting to you, it ends when the product is fixed. So part of what my organization does is, I mentioned we create processes for the engineering teams. This is a high-level view of one such process. You can see the stakeholders here, customer-facing engineering, P-cert, which is part of my work, and then the product engineering. So quickly, the customer reports the sighting. We have the customer engineering in a position to quickly triage the issue. And speed is the key here. We're going for speed. Customer engineering triages the issue. We don't expect them to be security experts. You know, take a swag at this. Do you think it's a bug or a security issue? And does it affect AMI generic code or generic product? We also have a business models where we also develop the customer's derived product. So they have to make that distinction. We're only really focused on P-certing AMI generic product. So if they triage it as a security issue that affects AMI generic product, that engages my team, the red. So we then look at it, we do a risk assessment, and we identify what component. This is, again, where we're not decentralized. This is more of a hybrid approach. We know who should be the vulnerability lead for that in the UEFI product engineering. So we'll route that issue to that person and go back and forth with them on the risk assessment and the investigation to see if we're indeed affected, and what the risk is to our product. At that point, once we get the risk assessment, we know we're affected, we can begin the advisory process. So you can get an advisory from us as soon as we know we're affected. While we're doing that, in parallel, engineering continues the process. They advise us on when they can have a fix at the modular component or package layer, and when they can have that fix integrated into a release. That's called a fix plan. You may get another advisory update as that additional information comes in. And this continues on all the way till you actually have some fixes which can be integrated in. We publish the fixes to the supply chain. As you can see here, depending on if it's us implementing the downstream partner's derived product or not, that's why it's striped, or if it's the customer doing it, you have that phase happening. So the customer product is, and the supply chain in whole is remediated. Something I want to point out here, even though we hear from the engineering team and they give us commitments on what release they're going to have the issues fixed in, are they really fixed? Did they really come through and fix the issue in that release, or did we just tell all of the customers that it was going to be fixed in an advisory and it really wasn't? So your P-cert should have some form of remediation verification, trust but verify. So my team has also developed a tool which, again, it's aware of the project. It knows which vulnerabilities affect each project. So of our advisories, it knows which ones affect each project, and it has rules implemented in it, and it can actually go look for the patches and verify that the patch is actually in that release. So life cycle. This can get complicated. So UEFI products at AMI, we have 70 active projects being maintained at one time. There are about double that are currently licensed. And you can imagine below each one of those leaves, you have multiple customers licensing each one of those projects. So this thing just expands out. We advise on everybody that's licensing code. So even if it's EOL, we'll tell the customers that they're affected. Each one of these leaves at the end of this graph represent one of those projects. The life cycle begins when we get a citing, right? So in this example, it's a customer ticket. I mentioned the engineering team will triage it. We'll get an internal ticket created from the customer ticket. We will route it to the vulnerability lead, which is at that package or component or module layer. And then they'll do their job, and they'll let us know if they're affected and what labels are affected. We will know which projects are affected based on this component level versions that are affected. So we've automated this. So back in the day, we used to send out emails and ask who's affected by these modules. We don't do that anymore. So we know the projects. So we know who's using the affected labels, and we can automatically generate tickets for all the affected projects, send them to the CRB owners, and begin that part of the life cycle, which is at the project layer. What release you can have this fix in, when can we have a patch, etc. So what we've done here, and again, we do talk to our BIOS teams. We're heavily integrated at this point with them, and I thank them. We've added P-cert specific fields to the bug tracking system. So as they go through the life cycle, they update these fields, and we have other tooling which scrapes all this information from the bug tracking system into our vulnerability management system. So it's all automated. We don't have to do emails, we don't have to ask about it. Why are we doing all this? Because responsiveness is the most important metric for reactive security or PSER. It's like, how fast can you get this fix done? Responsiveness is the measure of time it takes to reach each phase of the vulnerability. So we have customers asking, how long does it take you to complete your investigations, to get us a fixed plan, to get us the patch, to get us the release? And they're asking us. They say, we want commitments from you. We want this baked into SLAs. And, this is fine. This is good. I think this is good. And then another thing with responsiveness, when we get these sightings in, you have the researchers. They're always rushing to talk about their new find. And I don't know if it's always in a responsible manner that they do this. You can go back and forth with them and negotiate an embargo period, but a lot of times they're gunning for Black Hat or some other conference, and they want to talk about that vulnerability in that conference. And they use these heuristics like, we will use a 90-day embargo period or something like that. I mean, it's my opinion for our supply chain that's not even realistic. So I want to build this awareness within the supply chain, even with these researchers, that 90 days isn't responsible, and it's not giving enough time to the whole supply chain to remediate the issue before going public. So reasonable expectations. This is a little bit, if you're talking about a maturity level, if you can do this, you've got pretty good security posture here. It would be good if you can supply your supply chain your downstream partners with a history of responsiveness KPIs, or at least you're going to want to know that internally, so you can give them ideas of how fast it takes you to fix issues. And even, I encourage this. Ask your downstream partners for SLAs. Get them to bake them into the SLA. They want that because they have to tell their downstream partner how long to expect. If they don't know how long it's going to take for the upstream partner to give them the fix, they can't get that information to the downstream partner. This is from the UEFI white paper. I kind of wanted just to show that, look, this 90-day thing isn't reasonable. Here's why. This is kind of a worst case scenario. So the sighting happens within the silicon vendor, the silicon provider, so way north in the supply chain. It's got to trickle through the whole thing. A lot of times the downstream partners, they don't want the remediation from us unless it's a part of a release. I can understand, because it gets integrated into one of our releases. We go through the release process, which includes testing. It lowers risk for them. So sometimes they don't move until they get a release from us. But we don't do releases all the time. We have this release cadence, right? Quarterly usually. So we could have this fix early, and it could be available to them, but they don't want to take it until we release the product. So if we do that, and I kind of picked specific times in this timeline to exacerbate this, but I mean, you're looking like 10 months. 10 months here. If everybody waits for the release from their upstream provider before they take the remediation, you're looking at 10 months until you can do a public disclosure on this issue that was cited in the silicon vendor. So this slide, if you get a copy, it just kind of details all those bullet points. And how can we make this better as a supply chain? Don't wait on the release. Take the patch. So we release the patch before the release. You're welcome to integrate the patch. You're welcome to integrate a patch, test it out, release that downstream to the next supply chain partner. Of course, what's the trade-off? Risk. You don't get that extra testing, so there's a little bit of risk. But as a supply chain, can we do better? Can we work off batches? I don't know. But if we do, again, this is kind of best case. You can half the supply chain. You're still not 90 days. You're down to 5 months. So, 90 days, I don't know about that. This is kind of interesting. Even the going to the CSP is a patch. So I don't even know if that technology exists. You can't just like patch a crypto Dixie and update a ROM image with it on the fly in the data center. So even this is theoretical. So I mentioned about the KPIs. How do we determine how fast we can move in order to communicate that to the customers? I mentioned this issue, this ticket scraper that we have. So this guy runs every 2 hours, and it detects all of the bug tickets that are categorized as security fixes, everything that we're doing a PCERT on, and it scrapes the data from those fields from them and ingests them into the VMS. And when you set some of these fields, like your affected status or your fixed plan related fields, that indicates that you've moved on to the next phase of the vulnerability life cycle. So we can see which projects remediate things faster. We can see where the bottlenecks are. Is it a project bottleneck? Is it a phase of the life cycle that's taking longer than it should? You can crunch that data in a lot of different ways, but good stuff. And then you can bake that into your SLAs. We have an idea how fast we can move because we have all this data. We'll put this in the SLA, and you can tell your downstream partner about it. So this is the table. Once you have the data and you know how fast you can move, bake it into your SLA. Let your customers know. They have an expectation that you can move faster based on the severity, that you'll dedicate more resources and crank out that remediation faster if it's a higher severity issue. So yeah, go ahead. Rows are your relevant life cycle phases. Columns are your CVSS scores. Yeah. So again, included in your SLAs, offer those responsiveness commitments. I don't know if you want to tie any financial obligations to that. I'll recommend that. But, offer transparency. Let them know. Show them your stats. Show them your data. It's security. I favor transparency when it comes to security with our partners. Give them access to those KPIs. Again, they need this information so they can communicate it and set those expectations with their downstream partners. So once you have this stood up, once you have your reactive security side stood up, your PCERT stood up, a maturity level near this is very mature in my opinion, then you can focus on proactive security. So you can mine that data that you're getting, find out where your weaknesses are in your products, where your vulnerabilities are, and then you can start crafting solutions to detect those vulnerabilities earlier in the life, before the release. With SSLC, you have your training, your threat, all these things you can do shifting left. But in my opinion, automating and creating tools is the best way to do it. Create a tool that can detect that get set variable buffer overflow vulnerability before it goes to release. You can train on that all day long on how not to make those errors, but you're going to have churn, you're going to have turnover in the organization, you're going to have whatever else. But if you got a tool's the way to go. I don't want to go into the tools.
You have time. Take whatever time you need.
Okay, it looks like I got a little bit of time. I'll talk to them a little bit. I took the slides out actually. So crunching the data from last year, we had found that there were a lot of UEFI variable issues, mostly privilege issues. OS could do things with variables that they're really not supposed to be able to do. Some sightings were based on that the ability to do that, the fact that that attack surface was available. So we created it's actually a runtime tool. It doesn't look at the source code, but it'll scan all of your UEFI variables. It's good for QA to run. Lets you know all the UEFI variables that your product's using, and then it'll fuzz them. So it will, attempt to write to them, write corrupted data, larger, smaller data, and then it'll generate, it'll do a reboot, make sure it didn't affect availability, make sure it boots back up, and it generates a nice report for the QA tester to pass the development if needed prior to release. Another big one was the get set buffer overflows for gets the UEFI variables get set variable. So we created a tool to scan the source code for patterns that look like it might be one of those. So we have a whole system to track the results, and it compares results from previous releases, so it can identify new sightings. Those are then investigated by the engineering team. What was another big one? The top two, or COM buffer validation for SMI handlers. That was a big one for last year. So the tool looks at all your SMI handlers, verifies that you're doing proper COM buffer validation on those. So so that's what I meant by your reactive feeds your proactive. So we're happy. I'm excited about doing that. So this other stuff, we also do a compliance function here. So a lot of the SSDLC side, the proactive stuff like the code review, SAS and DAS testing, does your product support SBOM? This is still more decentralized, so we'll create high-level processes and requirements, and then we'll audit the teams on them and ensure compliance. So we'll say, show me your process specific to your product where you do code reviews or you run these tests, things of that nature. Okay, I think that's it. Yeah. Questions, comments?
We have time, so go ahead.
It seems like some of these tools are fairly generic. Is there a plan to make them available to the open source community for something like the variable testing tools?
Right. They're available internally right now. And, I'm a big proponent of securing the supply chain. So I'm in favor of making them available to a wider audience, including, because we license code downstream, right? So our customers derive products, they have the same code. The tools are capable of recognizing that product and doing all the same stuff. So yes, it's possible. We are not doing that right now, so we don't have an option to make them available to the downstream partner. But it's not saying that we're not going to do it.
Thank you.
Any question?
Yeah, so I think one of the outcomes of your presentation, just from the content, is that there's a significant latency for fixes to propagate.
Yeah.
From where you have identified the issue, you have generally fixed where it's actually going to land in the end customer. And if you look at, let's just take Tianocore, right? There's a lot of code. Right? Some of that code is chipset specific, architecture specific, intimately tied to the SIP, or let's say the ODM. And then there's a lot more code, presumably, let's say like the network stack, which is identified by the earlier speaker as a significant source of attacks and issues. There's a whole bunch of code which, maybe you have like an internal audit, you're looking at teams looking at it, and most likely it's just taken up as is. And so that stuff is not tied to a specific platform, but it's just part of the overall solution. So it sort of seems like, imagine if OS updates were treated the same way, where instead of getting like a Windows update, you'd have to wait until Dell would approve on that update, even for stuff that's completely irrelevant to the actual platform hand. So perhaps it would be nice to imagine a model where, at least for the generic portions of the firmware, that doesn't have direct conflict with SIP or OEM, you're able to deliver that directly to the end customer. The end customer, the CSP, or so maybe you could kind of split apart the firmware into like the really, really important parts that are coupled to the chipset and the hardware and the CPU that need to trickle down versus things that we don't modify or that the OEM and SIP have no input on. So it doesn't matter where you actually need their input in terms of approving it. So you can kind of fast track that and deliver it directly to the customer.
I mean, for like the BNC product, that would be more of a thing, I think. And that's what our internal teams use. We use a lot of open source, Debian-based in the BNC product, and we do a lot of remediations, but it's low level of effort because we're just upgrading whole packages.
Sure.
So you're saying, why you guys do that? Why do we have to wait on that? You just tell us what packages you're using and we can update it.
Not quite. I'm saying is, imagine you have like two firmware volumes, right? One is the one where all the SIP and OEM specific stuff go into, and then there's the other
It's proprietary, right?
So this one is obviously the update policies are controlled by the OEM. Another one is more open-ended, and effectively, I can download an update package, throw that in a USB key, and the firmware will just take that and store that in the second firmware volume. And yes, maybe I have a way of kind of safety mode where I can boot it more than that, but this lets me quickly apply patches directly from AMI, bypassing all the glue in the middle. Stuff that's not relevant to all these layers.
True, but you're missing out on integration services, testing services, and you're paying for that. If you're licensing a product from AMI, that's what you're paying for.
Okay, so
they don't
let's
want to
take
do
a
that.
bug
They
in,
want us to do it.
let's take a bug in, I don't know, HTTPS booting. What is the level of testing that you would expect your OEM to do? I would say it's insignificant.
Yeah. I mean, it's the downstream partners. They have the choice to do that. But like I said, they don't even want the patches. They want to wait on the full release and get the full
They
integration.
do, but the end customer might not. And this goes back to some of the other kind of what's having is like CSPs. They want to start to want to own the firmware lifecycle because they can do a quicker turnaround.
Okay, how are they going to get that fix integrated into the ROM image that you're using if you're like a CSP? Who's going to create that?
They're going to own the firmware for the platform. So that's the thing. If the IFBs and all these other vendors cannot figure out a mechanism to speed the process up,
Right.
then is it get large enough you're going to be able to say, well, forget it. We're going to
They could do that, but they don't license the code. So like an ODM may have access to the code, but the OEM doesn't. Our code, for instance. So yeah, they could. They would have to license
So
it.
again, right, if the existing IFB OEM ecosystem cannot figure out how to accelerate at least some of these paths, then again, if you're able to kind of quickly deliver code, based on your competency, like, this code entirely owned by you. It has nothing to do with OEMs on the end. Like, why do we wait on their releases to get it to the person? Right? If that doesn't happen, we see that as players get larger and larger, they start taking on functions for where they perceive the inefficiencies to be. Now, does it make sense? Does it make everybody happy? Probably no, but this is one of the reasons. Because you're talking about processes in your own company, and you're saying, like, here's how we make ourselves efficient, but you can't miss, it's hard to miss the whale, and then the whale isn't you. The whale are the other three layers of companies that are going to patiently wait until the cadence of the release.
I feel sorry for them. Working with the OEMs, when they're against these tight time deadlines to go public, and they know they have a massive inventory of products to fix. They're waiting on us, and by the time we generate something for them, they just have that much less time to react, so.
So if you can reduce the scope of the stuff that they have to deliver on, right, that's the better.
Yeah, good point.
Okay, I think that'll do it.
All right.
Yeah, just a comment on what was being said there. I'll come up so you can see me on the video here. We need to think about also the issues of, gee, this is being actively exploited in the field, and it's on the CNN evening news. And machines are getting bricked all over the world. How do we respond with that? Oh shit, we need to do something now, and get something rolled out to the field and get people updated immediately. So we've got to have a bypass process as well for those kinds of incidents. So I think everybody needs to think about that as well in this whole vulnerability management, shortening the supply chain and everything. What happens when you need to just break the supply chain and jump right into get this remediated and out there? So
Accept the risk, right?
yeah, accept the risk under those circumstances. Okay, thank you very much.
Thank you.